Hello, my name is Daniel Hadjevich. I work at AppDynamics in professional services as a solution architect, and I would like to talk to you about AppDynamics DEXTER. AppDynamics DEXTER stands for Data Extraction and Enhanced Reporting, and it provides an ability for you to take out the data from inside of AppDynamics' platform, preserve it, and analyze it with very interesting new novel ways. It works by collecting the data that was previously sent to the AppDynamics monitoring platform by our AppDynamics monitoring agents. It uses some APIs and some compute to convert the data into a variety of interesting CSV files and then load them into a variety of reporting mechanisms such as Excel, Power BI, and Tableau. Today, I would like to talk to you about AppDynamics snapshots data. AppDynamics snapshots are representation of an activity, a transactional activity that can span multiple executables, multiple threads and multiple executables, and various subsystems. On my screen, we have a flow map of a complex application. Within that application, we may have a set of business activities that we previously identified as important for monitoring. Here, we can look at the checkout e-commerce transaction. This checkout transaction incorporates inside of it a call into a Tomcat-hosted Java component, then uses a variety of web services to speak to an inventory component, drops messages into queues, and talks to a variety of databases shown on my screen. This is a very complicated execution pattern, and tracking it end-to-end is really interesting when you open up a given transaction snapshot. I will open a transaction snapshot on the screen right now in AppDynamics' platform. Here we could see specific items associated with every execution. We have some SQL queries here on the left. We have information about the errors that's available once you drill down into the call graph elements associated here. I can click at any point here and see what the error was. Here we have a shipping API that failed with an error 500. Thus possibly making this transaction end badly. So what if you wanted to analyze the data in multiple snapshots altogether? Within AppDynamics UI, we have an ability to take a look at some of the common elements inside of the transactions snapshots, such as the classes and methods that are used most frequently, and an expected SQL. However, this particular ability doesn't span beyond just a handful of snapshots at most. This is where AppDynamics DEXTER Snapshots report can close that gap. Here on my screen is an AppDynamics DEXTER Snapshot report. Its contents are listed in a table of contents sheet. Here I've interrogated 20 AppDynamics applications for the total sum of just a bit over 16,000 snapshots that themselves consisted of 40,000 or so execution components. Think of different thread handoffs, multiple processes involved in a transaction snapshot. Between them all, there were 44,000 exit calls made, so things like database calls, external web service calls, and such. And then we had about 10,000 errors captured, roughly, plus or minus. There's other components in this spreadsheet that are documented in AppDynamics DEXTER repository. Well, most interesting things about most snapshots is the types of components that they talk to, which are called exit types. Let's investigate what we have going on in here. So I can go to the exit calls.type pivot table, which shows me the types of calls that the components were made and their details. So here we have 20 applications, between them all making just a huge plethora of different calls. Database calls, the calls to HTTP destinations, the Mongo database calls, the calls to cache, the email server, Amazon Web Services, and so on and so forth. Let's take a look at the specific activities associated with just JDBC invocations. I can filter this particular pivot table. I can open up the pivot and I can see the list of all the different calls that were made from here. Using Excel pivot table, I can add an additional dimension or a measurement that were previously created by AppDynamics DEXTER as part of the extraction and indexing process. In this case, I'm going to grab in SQL clause type and put it right after the exit type. Collapse it furthermore. Here, now we have different types of SQL connectivity that you can make, select statements, insert statements. The graph above tells us that select statement is both frequent and probably the slowest of them all. So I can further drill down into my select statements and filter, keep only selected items, and can see which queries happen to be the worst performing right here. Right immediately I could see that there's a certain select statement that is both frequent and slow. And it seems to be, let's expand it out, it seems like this particular statement is in 2 of my e-commerce applications, and it spans the business transactions that are important. Checkout and checkout mobile are the transactions that run money through it. So there's my optimization target should I decide to do something about this statement. There's a second one down here called select star from user offers. Also seems to be fairly frequent and kind of slow, and we can see it spans, it's in a different application altogether in a business transaction called confirm order. Let's take a look now into the different view into the exit calls. Let's look at the exit calls that have errors. So some of the queries that we may invoke may have errors associated with them. So I just will use the filter called has errors and set it to true to indicate only the exit calls that had errors. And now I have the specific errors grouped together associated with a specific detail of calls. So if I take a look at just the HTTP errors, filter, keep only selected items and HTTP things, I can see that there is a certain error that keeps happening over and over and over. IO exception, server returned error 500. I can see exactly what I was trying to access. In this case, I was making an exit call that is visible in my address bar. If I can expand this out a little bit here, I can take a look at what it looks like right here. And if I wanted to do maybe additional investigation for the most frequent no HTTP response exception, I can use the sorting and filtering capabilities, like such as sort largest to smallest, to bring the most frequent errors to the top of my screen. So taking a look at what else is inside of this report, we already saw the exits, but we also have additional things such as the errors tab. Now, let's not get them confused too much. We just looked at the calls to databases and calls to external services that had errors. But those are not the only types of errors that may occur in customer systems. If we take a look at the errors.type pivot table, backed by the table of data exported out from AppDynamics earlier, here we have all the errors that are present in here. Let me find an interesting, juicy exception. How about the Amazon S3 exception right here on my screen? Let me zoom in a little bit so you can see it better. And I can see that Amazon S3 is producing tremendous amounts of access denied 403s. And looks like it's the same error happening over and over and over. Let's see which business activity it's in. It looks like a transaction called Process Trade Cloud. You can do other kind of analysis of this data if you wanted to see the raw input into it. You can always click on the See table up in the top right and investigate the table and filter it however you'd like to see fit. So for instance, if I wanted to find those Amazon S3 exceptions, I can use filtering capabilities here and see all the errors listed here with their detail, message, and the types. I hope you enjoyed this particular presentation of the snapshot exit and the snapshot error data, because we're going to be continuing it in the next session, looking into call graph elements. Thank you.